For this lesson, we're going to be looking at solving linear inequalities. Much of this lesson is very similar to the solving linear equations in the fact if you're trying to get the x by itself. So if you have a problem that has a distribution property, you should take care of that first. Make sure you combine the like terms on each side of the equation. Move all your variables to the left, move all your constants to the right, get the variable by itself, solve it, and then check your solution. The difference between solving a linear inequality and solving a linear equation is that you've got to remember that whenever you multiply or divide by a negative number, sorry, typo, um, you have got to switch the direction of the inequality symbol. So if you are working things out and all of a sudden you have to divide each side by 5, then you leave the inequality symbol alone. But if you're working things out and in the process of getting the variable by itself, you have to multiply each side by a -2. Because you're multiplying by a negative number, then that means that whatever the symbol is going to become the opposite. So if it was greater than, it's going to become less than. If it was less than or equal to, it's going to become greater than or equal to. All right, so that red box is really important. Okay, so let's just start off with a pretty basic example. This one is -5x minus 6 is less than -19. So we don't have any distribution. We don't have to combine anything, any like terms on the same side. So we're just trying to get the variable by itself. So we're going to add 6 to each side. Okay, so this -6 and this +6 cancel out. We still have the -5x. There's no need to switch this inequality sign. We just added. That wasn't one of the reasons. And you get a -13. So our next step in order to get the x by itself is to get rid of this -5. So we're going to need to divide each side by -5. So right here we divided by a negative number. So you've got to remember that when you go to do this, this guy has to switch directions. Okay, and -13 divided by 5 is 13/5. So your answer would be x is greater than 13/5. And if you were looking at a graph of this, that's, here's 2, here's 3, here's 13/5. That would get an open circle because it's not equal to, it's just greater than. And we would head towards the bigger values. So any number in the shaded region here would satisfy this inequality. It could be an answer. So you could say 3, 4, 5, 14/5, anything like that. Okay? All right, let's look at another example. Example 2. Here you do need to get your x's together. We don't have any distribution. We don't have to get like terms together on each side. So we're ready to just start getting all of our variables to the left-hand side. So we're going to take this -3x and we are going to add it to each side. This is going to cancel those out. So keep in mind that's a 1x plus 3x is going to give us 4x plus 22. We're going to leave our symbol alone. We haven't done anything that tells us to switch it. All right, we're going to move our constants to the right. And we're going to subtract 22 from each side. These guys are going to cancel out. Again, we leave our inequality alone. We haven't done anything to switch it. Divide each side by a +4 so that we can get our x by itself. And x is going to be greater than or equal to -8. So in this case, I did not ever have to switch the inequality symbol because I never multiplied or divided by a negative. All right, and so if I were to graph this answer, here's -9, here's -8, here's -7. This guy I'm going to fill in the circle because he is also equal to, and I'm going to head towards the larger numbers, larger or to the right. And so 0 would be an answer, 2 could be an answer, -7 could be an answer, -7.9 could be an answer, -8 could be an answer. I just have to stay larger than or equal to -8. All right, so those are just basic inequalities. You'll also be exposed to compound inequalities, and you have compound inequalities when there are two different inequality statements in the same problem. The main thing is to focus on whether it's an and problem or an or problem. If it's an and problem, then your solution would be where both of the statements are true. If it's an or problem, then you're just concerned that at least one of the statements, can be both, but at least one of the statements is true. Okay? In order to belong to the solution set. So let's look at some examples of this. This is an and problem. Okay, so there's two different inequalities here. We have this inequality right here, which is 5 is less than 2x plus 3. And we also have this inequality right here that says 2x plus 3 is less than or equal to 11. Okay, so these are two different problems that we have to work out separately. So we're going to subtract 3. You get 2 is less than 2x. Divide by 2. 1 is less than x. Okay. Now, you'll notice in my rules, I always said leave your variable on the left. That's just a personal preference for me. That's not wrong to state your answer like this, but typically, standard form, the way most books are going to write it, you're going to see the variable on the left. So you've got to really pay attention to what that problem's saying. If you think about from elementary school when they talked about the alligator mouth eating the bigger one, if the alligator mouth is eating the x, it needs to continue to eat the x. So when you switch from left to right, you'll flip the inequality symbol. So we would say x is greater than 1, and then we're going to work out the other one. Subtract 3 from each side. 2x is less than or equal to 8. Divide each side by 2. X is less than or equal to 4. So we need to figure out numbers that are both, because this is and, greater than 1 okay, which is everything over here, and we need to be less than 4, which is everything in the green. So we are concerned where both of these things are happening, which would be right here in between the 1 and the 4. So 1 is not an answer, 4 cannot be an answer, but 1.2 would work, 3 would work, 6 would not work because it's not less than 4. So you have to be in there anywhere in between 1 and 4 would be the answers you're looking for example, 3. All right, the opposite type is the or situation. So again, you've got the two inequalities. You work each one out. Subtract 9 from each side. You're going to get 2x is greater than or equal to -6. Divide each side by 2. X is greater than or equal to -3. Or, on the other side, subtract 1 from each side. -5x is less than or equal to -1. Divide each side by -5. I'm dividing by a negative number, so I need to flip that inequality symbol around. And so this guy would be x is greater than or equal to 1/5. So this is an or situation. So all we're saying here is you got to be bigger than 1/5 or bigger than -3. So anything in here would work because you're going to be, you know, if you're back here, you satisfy the green. If you're up here, you satisfy the red and the green. So as long as one piece of it works for either the green or the red, then it's an acceptable answer. So or is when just one thing happens, and is where both have to happen. All right, one quick little SOL trick. If you're looking at this problem, you got this multiple choice going on. Of course, you can work this out. You get 15 is less than 3x. Excuse me, 15 minus 3x is greater than 3. Subtract 15 from each side. Now what they're banking on here is that you forget that when you divide by a negative, you need to switch your inequality. So if you were to work this out, you should get x is less than 4. Okay? So then you need to pick numbers where x is less than 4. That means it can't be 4. So if it can't be 4, this guy's out and this guy's out. So you've already eliminated b and c because you know we can't be 4. And then less than, it can't be 5, 6, or 7. So you're looking for um, anything in choice A. 1, 2, and 3 are all less than 4. Are those the only answers? No, those are just numbers that belong to the solution set. So we would pick A here. But if you forgot about this, then all you have to do is just try different numbers in the sets. So if we had tried 5, and you plug 5 in for x, you're going to get 15 minus 3 times 5. So 15 minus 15 is 0. Is 0 less than 3? No. 0 is, oh, excuse me, is 0 greater than 3? No. So you're not going to be able to choose 5 because it doesn't work. And all of these guys had 5, so that also would help you figure out that the answer is A. So a lot of times when you're dealing with the SOL, if you forget the step by step by step method of solving an inequality, you can use the answers just by plugging them into the inequality or the equation to help you figure out what the correct answer is. All right, so if those are a couple of examples, so if you'll go on and do your classwork assignment with this, we'll see how you do with it.